useful enough to put into a presentation. So you can go ahead and start if you want. The other thing I'll let you know is that, yeah, go ahead. On GitHub, under my account, J. Conway, I've got a repo with the same name as this presentation. And you can see the PDF is actually in there, and then there's a directory called scripts. And so some of the scripts that I'll show you during the presentation are all right here. If you wanted to download, look at them, whatever. If you find them useful, feel free to use them. I think I was smart enough to put some kind of a, no, I didn't even put a license on these things. It's probably not a good idea, but anyway.
I like the -U.
And so you can also see that this is a presentation I actually gave at PGCon in June. As I said, I've been with Postgres community for a long time. I've been a committer on the Postgres project since 2003. Haven't been super active for about the past 6 or 7 years, but I changed jobs at the beginning of July to a new company called Crunchy Data. And part of my job now is actually to interact with the community and start getting more active. So I've been a lot more active on the list recently, and I'm hoping to just increase that in the near future. So probably most of you guys know this, but maybe you don't. What does Shebang mean? It's a contraction of hash and bang. It's kind of interesting in these politically correct times. When I submitted this paper to PGCon, they said, well, we want you to do this talk, but we're going to change the spelling so that it's S-H-A bang instead of S-H-E bang because we're afraid people may take it wrong. And I actually did some Googling, and if you look on like Urban Dictionary, shebang comes up with this definition, the Unix definition. If you look up shebang with an A, it's much more colorful. So they actually went the wrong way with that. And so this, when you start a typical shell script, this is the very first line, and that's telling the operating system what interpreter you want to use for this script. And this can actually be something like Perl or Python or
PSQL.
I've never done that, but I have heard of people doing that. I have heard of people doing that. So what I'm going to cover here are the pros and cons. I'm going to give you an overview of a function library and why I use it and what's in it, and then some specific scripts that are demonstrating Postgres specific techniques, as I put it here. So executing SQL, setting and getting data from script variables, and keeping your Postgres functions in sync with the scripts. And then some more general techniques that are also useful when you're doing this kind of stuff with Postgres, like locking, doing work in parallel, and making sure things get cleaned up. In terms of the pros, Bash is, it's relatively easy. Shell scripting is relatively easy. It's great for automating repetitive tasks. It's reasonably easy to debug once you know how to do it. And I'm going to show you a hint on how to do that. All POSIX compliant systems have some kind of a shell, and pretty much all of them, I think, these days have Bash available. And there's a huge ecosystem of command line tools that you tend to use in your scripts. So you don't reinvent the wheel. When you need to do regex on something, there's a tool for it. When you need to sort, there's a tool for it. Cons are, if you've got a really complex task, it's probably not such a good choice. Relatively slow. Like I said, for 3 years, I used it for all kinds of things and never found it to be too slow for my use. But if you're doing something that's really performance critical, you might find that it's too slow and that you'd be better off using Perl or Python or maybe even some compiled language like C. It tends to be less robust than other more formal programming languages, although there are ways you can make your scripts more robust, and there's actually lots of information on the internet if you Google for it about best practices when it comes to writing shell scripts. And there can be some portability issues in terms of not only across different operating systems like BSD versus Linux, but across different Linux distributions, and even across different Bash versions within a Linux distribution. There, you might run into some compatibility issues. But that said, a lot of the time when you're doing this kind of thing, you're doing it for your own use, and you have a relatively homogeneous environment often. So the Common Functions Library, the reason I use this is to aggregate Bash functions that I'm going to use over and over again. I don't want to have these functions in every separate script, because then if you figure out a bug or you want to do an enhancement, you've got to do it in all those places instead of in one place. So it prevents proliferation of redundant code, and it's centralized for ease of testing and version control. So this is the top portion of my sample, at least, Common Function Library. This first line, set -u, what that instructs Bash to do is basically throw an error if it runs into a variable that's undefined. If you don't have that, then you can use variables, you can reference variables that are undefined, but you may get unexpected results when you do a comparison and you forgot to define the variable. This way you'll be sure that an error will get thrown. There are other ways to accomplish the same thing on a per variable basis. I don't think there's any examples of that on this particular slide, but later on I'll try and point one out. Basically, when you've got a variable like this $, curly bracket, some variable name inside, at the end of the variable name you can put a question mark, and that'll cause that one variable to error out if you're referencing it when it's not set. This plus X, if you use -X, that's going to give you very verbose debugging. So you'll see basically everything that Bash is doing as it goes through your script. You definitely don't want that turned on all the time. You might find that you want it turned on sometimes, so by putting it here, it's just convenient. You can come in with an editor, change it from plus to -X, and now all of a sudden you're being a kind of very verbose debug mode, so you can figure out what's going wrong with your script. I also find that it's useful to have a variable called debug, which then you might wrap around just specific areas of code, so that you don't have to get this really verbose output if you just want to debug one smaller area. This section here is setting the base name of the script and the base directory that the script is running from. The reason I have it in this conditional is that if you source this function library at the command prompt instead of having it basically loaded into a shell script, you'll get an error if you just try and do this down here. So this part here is basically figuring out, are we running this thing as being sourced from the command line? So I'm going to define that term. Sourcing means you're literally reading the code in from a file as if you had typed it in right there at the command line. And so if you do that inside of a script, it's kind of like an include. If you do it at the command line, now your Bash session has the result of whatever it was that you ran. So if you define some variables, they're now there in your session. If you created some functions, they're now there in your session. They're available for use. So sometimes when I'm debugging, I find it useful to just source this common lib, and in order to interactively test the functions or something.
I lately have followed is I source those. And what it does is it takes me to the directory where I work on that project. It sets environment variables as needed. In the case of Postgres projects, it makes sure that Postgres is running. And then, now, betray my politics, it launches Emacs. But it's nice because there's all that annoying stuff you have to remember to do before working on a project, and you forget some of the things. And
Yeah.
the great thing is that when by sourcing it, you now have everything set up in that shell, so you can just work on that shell, and everything just works.
So basically, just what you said there. If I type PG95, what I do is I source a script. Let's see if I can. Same basic idea. That will source this file, which sets a bunch of parameters. So when I'm working with Postgres, by typing PG95, I'm now in my 9.5 instance of Postgres. And I can run Postgres 9.5, but I can also open another tab and do PG head, which is going to put me into the Git master. So I can run 2 or 3 different versions of Postgres at the exact same time on my laptop if I'm doing Postgres bug fixing, for instance. No, it just puts me right into my source directory. It sets all the environment variables for like LD libpath and path and PG data, and everything is just in that session is now set up so it all points to the correct environment so that I can literally run any of them without thinking about it.
That source is what you use for your function libraries also. Every time you build a library, you can source that in your script if you need that for your setup.
Right, and I'm going to show you an example of how that's done down below.
You can source or you can do dot also.
Well, dot is source. It's just a shortcut. So you can type the word, literally type the word source and some file name, or you can just say dot file name.
The word source comes from the C shell, and dot comes from the bourne shell. And they thought, well, depending on where you're coming from, let's make it familiar.
I like dot because it's short.
Exactly. But when you say something like dot space dot slash dot foo,
It can get obfuscated when you're, and in some environments they prefer that you be more verbose because it's more readable. So the other thing I'll mention here is this set minus E, which is similar to the set minus U, except now this is going to tell Bash, on error, I want you to exit. So it's basically going to exit immediately on error. You may or may not want to do that. In some cases you don't want to do that, but I've found it useful in general to have the script bail out when there's an error. So when you combine that with minus U, that means anytime the script hits an undefined variable, it throws an error and it exits the script immediately.
But minus E is for anything that you run that has a non-zero basic code.
That's exactly right. And there are times where you actually need that. And so you'll see, actually, I think I've got an example where I have to wrap something in set plus E, do something, and then go back to set minus E, specifically to turn that off. And one of the reasons you might do that is because there might be a variable that may or may not be defined, and if it is defined, you want to use it, and if it's not defined, you want to set it to some default.
but you can always do that with a colon equals, so colon dash rather.
Yeah.
Yeah, there are, but it's really nice to see that, because one of the worst things that can happen is you do something interactively and you're there, so if something goes wrong, you don't just barrel on and continue. But as soon as you throw it in a script, it's now a moron.
Yeah, well, and the other thing is, I mean, being a database guy at heart, you like to see some group of things happen sort of in a transaction where it either all happens or none of it happens. So what you don't want is your script to like run into an error. It doesn't do some critical step, and then it just plows ahead and ends up deleting stuff and who knows what.
It also causes a lot of hours of debugging frustration, though, if it continues on and
Exactly.
it possibly does something that wouldn't have done if it had done something correctly, and then it creates an error from there, and then you're sitting there trying to debug that error instead of the real error that's above.
Right. So then I also typically like to specify an output directory, and again, you'd have to tailor this for your own environment. A lot of times it's easy to just say wherever the script is running from, create an output directory for any log data that you want. In this case, especially for this presentation, I was working with SQL files, and also in other contexts I work with SQL files, so you might want to have a special directory that's specifically for those. One of the examples I have down later in the presentation is this locking. So I've defined, these are basically like an enum. So I've said unlock is 0, no wait is 1, and block is 2, but that way I can refer to these variables which are readable instead of magical 0, 1, and 2, which then it's not evident what you're doing when you read the code. You also often will want to date timestamp files, your log files, other types of output files that you might have. So one problem with being in presentation mode is you can't, if you're not familiar with what this will do, so that'll give you year, month, day, dash, hour, minute, second. You can then concatenate that to some kind of a temporary file name or to some kind of deterministic file name, however you want it. I've specifically done year, month, day so that it sorts.
It's the ISO standard for dates, which nobody follows.
I generally do.
But no culture does.
That's true. And then this is this section of code. I don't have this turned on by default, but if you change this 0 to a 1, what it's going to do is tee your output so that it goes both to a log file as well as to the terminal. I found that often when you're automating things, you want stuff to go to a log file, but while you're debugging, or if some of these scripts you might use both interactively and like on cron or some other kind of workflow, and so you want to be able to see the output to the screen, but you also want it captured, and so this is just an easy way to have both. And you can see, like, if you were to try and Google for how to do this, I don't know how you Google for that.
You used to be able to, it was fine, and then people decided to get smarter.
Yeah, I've tried escaping things, but it just it ignores characters like that,
It does.
special
There's an
characters.
advanced mode where you can turn off indentation, it's still a pain in the ass.
And then once you get through all that, there's going to be a bunch of functions. And they're going to typically look like this. There's going to say function, it's going to be a function name, you've got curly brackets around it, it's going to have some variables that are defined, and then you're going to do something. So now, this is showing you, now that I have this common library called common.sh, this is kind of the beginning of all of my scripts. So if you look at any of the scripts that I've got here, you should see that this part up here looks pretty much just like what that slide looked like. So one of the problems is you have to kind of bootstrap things. So I end up defining this base dir again, and all this is doing is figuring out what is the directory that this script is actually being read from, and it's doing it in a canonical way so you get actually a full path and not like /, which is important for some uses of this. And then it's going to define common lib, which is going to be this. It's going to expect to find this common library file in the same base dir as the script. You might want to change that. Maybe you want to put it in. user local share or something, I don't know. So you might hard code that, not have to do all this. And there's your keyword source, common lib, and this is a test that's saying if that file exists, source it. If it doesn't exist, I'm going to echo an error message and exit with a non-zero code. So in Bash, basically anything that's run successfully exits with a 0. Anything that's non-zero indicates non-success. Typically things will indicate error with a 1, but some programs are more sophisticated and have special codes to differentiate different types of errors. Actually, PSQL is one of those.
You have to be careful because 0 does not always mean that whatever you're doing is successful. It just means the command itself, complete, is successful. It doesn't mean it actually accomplished whatever task you wanted it to do.
That's a good point.
That's been by now a few times.
It's a convention.
Yeah.
If you have multiple failure modes and only one success mode, then it works beautifully. But if you have multiple success and multiple failures, you could use, for example, even log, or anything else you want. But you only have 0 to 127, I think.
Right, I think so.
But
And if you've defined set minus e above, if you do anything returns non-zero, your script is gonna exit. So that could be another reason why you want to not use set minus e, or at least bypass it for certain
You
portions.
see the class could be used 0 for failure points. You use the true false ability.
yeah, it's inverted.
Yeah, I'm just wondering, can you do something similar with that? By
If
using
you're inside of double parens, then you get C logic.
It's probably not. You can do anything you want, but it's not wise because then you're bucking all the conventions, and anyone else who then
Well, I was
uses your
wondering,
script is.
to test for coming back for non-zero, okay, it failed, I'm going to stop doing
Oh
other
yeah,
stuff.
there's ways.
Yeah. Okay, so now we're going to get to our first function in the common library, and just call it exec SQL. You notice each of these variables has been defined local. If you don't define it local, then it'll exist outside of this function once this function has been sourced. So you don't, in order to, this is one of these, Bash best practices. If you want to protect yourself from surprising results, you should define your variables local if it makes sense to. This $1 means the first argument, $2, so on. These are the arguments being passed to the function. I like to create this function so that it takes a host, a port, a database name, a username, which makes this thing able to basically connect to any Postgres anywhere on your network that you can reach. If you don't do that, people that are thinking in scripting tend to think always of the local machine, but you might not want your script to be restricted to just the local machine. And in fact, some of the things you can do with Bash scripts are automate things similar to the way you might use Ansible to do it. Although maybe in a less convenient way or a less robust way. Yeah, but for quick and dirty, you can definitely make good use of it. DLM is I'm going to specify a delimiter. So whenever I execute SQL, I'm going to get some result back. I want to be able to specify what delimiter is going to be used between the returned columns. And then the last piece is the SQL that's actually being executed. I think on the next slide I go into some more detail about this syntax, but basically what I'm doing here is taking that SQL, I'm echoing it out and piping it into the psql command. This -v says set this variable in psql on error stop equals 1. If you don't do that, then psql, if you have multiple statements that you're, like say a SQL string could be multiple SQL statements with semicolons all appended. If you don't have this, then you might, the first one could error, but psql will just keep executing. It will, because the last one succeeds. I think it's only the last one that determines the output of the the return code of PSQL, I think.
So what's the benefit of echoing versus passing it the dash C?
Okay, so yeah, we're going to talk about that on the next slide.
That's the problem with the
So here's some explanation of this command. If you pass -C, it will not honor on error stop, and that is because of the specific way that it gets executed. With -C, it's basically a single call with the entire string to the back end, and the back end has no way to do on error stop. Whereas if you pipe it to PSQL the way I did, then it will honor that on error stop, just as if you were reading a file from PSQL.
So what happens if we do set error stop with your SQL itself? Then you can do it set dash C?
It doesn't work. The exact reason I'd have to play with to tell you again, but just trust me, it doesn't work. I mean, I think I've got an example. Yeah, no, I guess I don't. I've got an example somewhere that, actually it's in an email that I sent to the list that illustrates exactly what the problem is. And I'm still on the hook to update the documentation to make it more clear, actually. So on error stop will make sure that it does stop on the first error. QAT and then -F delimiter. So it's going to be quiet, unaligned, tuples only, field separator set. So basically, when you're running PSQL, you know, there's like a header that gets output. There's everything is kind of spaced in a way to put it in columns. There's extra characters and all that nice stuff, but you don't want any of that when you're scripting. You're just going to have to parse it out anyway. So this is going to make sure that the output that you get is basically just the result variables.
Is that a single command or is it quiet mean?
Three.
It's 3 commands.
Yeah, Q is quiet, A is unaligned, capital A is unaligned, and T is tuples only.
So the tuples only says you're going to have data with no headers. Unaligned means we're not going to pad anything for the pretty.
Right.
And quiet means.
Quiet means no prompts, nothing else. And all of this stuff, by the way, if you're not familiar with it, the documentation of Postgres is really good. PostgreSQL.org. Documentation is right here. There's a whole section on.
Client interface. Why isn't it there?
It's actually.
There we go, under
Oh.
server programming, PSQL. Oh, no?
I'm a little surprised. I thought it was like a client, but I guess not. It's a client, but not a client interface. Was there a section?
It's
for
right here,
clients?
client
There we go,
applications.
Client applications, yes.
So you go reference client applications and then PSQL, and you'll get a good description of all this stuff. And actually there's man pages as well, so if you went to here and did man, provided I built the docs on this machine.
It only happens when you're giving a presentation.
Yeah.
How about just PSQL -L?
Yeah, that will also give you.
Yeah, that'll give it to you too.
It's usually not as simple, but yeah.
Let's let that run while I'm. And then this, as I described before, -H host, P port, capital U user, and D database name gives the connection info.
You're not pressing the password.
The password will get prompted unless you've set PGPass or trust. And usually in an environment where you're automating, you want to use PGPass. It's much better than using trust. And basically anyone who can get to your user directory already owns you.
Yeah, that's true.
That's the general consensus. So there's a file called .pgpass. Typically goes in
Our
the,
security folks might have done that. Yeah, we could use that. Okay. And I'm coming from a Windows environment. So
yeah. So that lives in the user home directory. It's nominally a hidden file, although anyone who's ever used Unix or Linux knows how to find them. And that will contain basically a mapping from a host in a database to a password, it'll automatically get fed.
But I like the fact that if the permissions aren't set right, it fails.
Right.
So with this syntax that you're using, you are forcing everyone to use a host, port, user ID, and all this.
The script is forced, not necessarily the user.
You can,
If your script is only ever going to use local stuff, then you default it to the local stuff.
Where you can make it more generic.
or you can do the script more generic where you can test if the variable is empty, and if it is, then you can assume it's local. You can make these much more.
You do have environment variables for PSQL, where you can define.
Yeah, you could do that.
database.
So
So that's another approach.
you'll see in, I'm going to get to this later on anyway, but most of the scripts that access the database are going to have something like this, right? And so if I'm only ever going after one thing, I just put that in the script. If I want a script that's going to be driven by the user, then I wouldn't set those, and I would set them based on arguments to the script. Or I would default them if they're not provided, and that just makes the syntax of the script a lot more tricky, but you can do that easily.
So I have done similar thing in one of the project. Later on, what I identified that there are certain variables that you can export and set the values there. PG
Yeah.
database.
Yes, you
those
can.
things. That way, you're not hard coding, and you have to only define what you want to use.
That's another way to do it. Depends on the environment you're in. It may be the preference of the people that you're working with that you don't do that.
Exporting stuff can leak, but an alternative to that is anything in the form of variable equals value that is to the left of the command name will be in the environment of that command.
That's true.
but
That's
will
another
not
way to do it.
exist afterwards. So you could do that.
Passwords, that's what usually used to do. PG password equals whatever space and then the actual command, so that way the password's only staying with the script. So,
Right,
Yeah. There's more than one way to do it.
as usual.
there's just a security one.
Yeah, that would be jelly. Asking yourself, how can I make this more local, is always a good question. Good
Right.
to ask myself.
Yeah. So this is similar to what I just showed you on GitHub. On most of these slides, in order to fit them on the slide, I had to kind of compress stuff and leave some stuff out. So, when you look at the script, all of the scripts at the top end up having all this common stuff in it. And then on my slides, I typically start at this part and show you what's below. So you'll see like a comment that says, all the same stuff is there as it always is, which is just loading the common lib and erroring out. So that's what this means here. And then this is setting. So this is kind of an interesting thing that I ought to point out is that typically when you think of a host, you think of an IP address or a host name. If you're working on the local machine and you want to use Unix sockets instead, then what you put in here is the directory for the sockets, which defaults a lot of installations at least to /temp. I think on Debian it may default somewhere else.
No, it's not that.
Yeah. It's not temp? That's changed recently, I think.
They like to be different.
Bear run or something.
And maybe in var run. I think now the defaults for the Red Hat variants and the Debian variants and later releases has been to have a multi-version capability. And so they typically have a directory for each version, so it's no longer in temp. If you build from source, that's what it defaults to.
Yeah.
But in any case, as long as you know where that directory is, you can specify to use sockets this way, which is going to be nominally slightly faster. You do still need to specify what port you're running on. Postgres defaults to 5432. If, like me, you tend to run lots of different versions of Postgres simultaneously, then you have to assign specific ports.
Question. You were just saying that you set the /temp if you're using a Unix socket. You still set the port?
You do.
Interesting.
Well, the file name gets named based on that port, because you
Yeah.
can do the same. It's the same concept, because basically instead of being an actual network port, it's an actual pipe.
run multiple copies, even of the same version of Postgres, on the same machine, each running on different ports if you wanted to have multiple instances of Postgres.
Okay. Yeah, my only experience with databases and sockets is MySQL. It's always revolved around MySQL. So it's kind of a different concept. Okay, cool. Thank you.
I think I can do the same thing, usually not.
So this is just showing you the use of the function that I illustrated before. So I'm setting all of the variables for the connection string. My delimiter is just going to be a space. This is my SQL statement. I'm just selecting the process ID and time minus the state change, which gives me an age from pgstat activity, where the database is the current database and the state is idle in transaction. So this is telling me all of the connections to my current database that are idle in transaction, which is generally a no-no. You don't want idle in transaction for more than ephemeral stuff.
Start transaction.
But you'd be amazed how many places make the mistake. A lot of times they don't even know it because they're using some kind of ORM that's doing it to them.
Yeah, if you're using a connection pool manager, almost guaranteed you're going to find tons of those.
But you don't want that because Postgres ends up with maintenance problems if you leave connections idle in transaction. I ran into I was doing training at a client in the UK a few years back, and they had an app, a GUI app, and for some strange reason the grid control that they used on the GUI app, in order to allow the grid to be editable, basically started a transaction and left it open. And they would run this thing on equipment. It was collecting data on equipment and controlling equipment, and it would run for months at a time. Caused them all kinds of problems. So anyway, now that I've defined all of those variables, I just simply call my function, and it's just going to send back the result. So this is another variation on more or less the same thing, except instead of a string, it's going to take a file as an argument. Pretty much looks exactly the same, except now I've got this -f with a file name. So this can be useful if your generated SQL needs persistence, or if you're executing the same thing over and over again. It's very useful if you have problems with nested quoting. It's one of the reasons I've used it, because the nested quoting stuff can drive you insane. An example of a place where I've used this is there was a script that I wrote. The desire was to be able to, quote unquote, lock people out of a database. But then there were all of these exceptions. I want to lock everyone out, except I don't want to lock out the Postgres super user, and I don't want to lock out the user that Sloaney runs as, and I don't want to lock out the replication user, and oh, by the way, if there's some ETL running, I want to let that complete, but then I want to lock them out, and I might optionally want to give some other people the option to stay in, but everyone else I want locked out. And it turns out that there's not a really easy way to do that, particularly with super users, unless you want to start monkeying with pghpa.conf, and that's not so nice either. So the best way to do that is actually to set a login, like alter a role and set it to no login. So once you alter the role and set it to no login, and then actually figure out who's logged in and forcibly kick them off. But if you do that, what happens when you've locked everyone out, and then in your workflow that's now running because everyone's locked out, some kind of maintenance, some users get created or some users get dropped. Now when you go to unlock them, you have no idea who was what before, because you may have had roles that were no login already. So the easiest way to handle this was, and I think this is maybe one of my examples at the end of this presentation, but The easiest way to handle this was figure out basically who you wanted to lock out, spit it all out to a file on disk, execute it, which locks them out. I use that now function to date time stamp the file. I have another file that keeps track of what's the most current one, just in case I try and lock people out more than once. I also actually use the locking at the bash level to prevent it from running more than once. And then when I'm all done, I can restore things exactly the way they were. So this is an example of using that. In this case, I'm actually going to dynamically make my file. This is an example of how you can create basically a random temp file name. This will have 6 random characters in it using maketemp. I didn't talk about this earlier. Most of you guys are probably familiar with it, but if you've heard the term backticks, when something is in backticks, it's executed in a separate shell, and the result is returned. And that syntax is actually considered to be deprecated. Well, you're not. Most of the guidance I read says you shouldn't use that anymore.
Yeah, I like this better anyway.
This syntax is basically the same thing, where you have $, parenthesis.
I mean, it nests. Backticks don't nest.
That's true, and you can nest these.
Yeah, so these are better.
Yeah.
I still use backticks for simple things, but this is really nice when I need nesting.
So now I'm going to basically take that same query I had before, and I'm just going to echo that into this temporary file that I created, and then I'm going to use this other function to execute it.
Takes the switches out of that whole command line. That's all it really is. But it makes it easier to read if you're just trying to scan through things. Hey, man. Welcome.
Pull up a seat.
Join us. There's not that many of us.
Whatever's coming.
Sorry for so late.
It's okay. You've missed quite a bit. Maybe you can let me know how familiar are you with bash scripting to begin with.
Okay, I see. So I'm familiar with a little bit, not very familiar. I actually use SQL for SAS. I'm a SAS user, so I was actually hoping to get some information in that area.
So using bash scripts to run SAS?
No,
Or
I just I use SQL in SAS.
in SAS.
In SAS to write SAS programs.
Okay, and are you running it against Postgres?
No.
No. Okay. Well, we're not going to cover SQL language itself specifically, although you'll see some examples of that in here. And when we're all done, if you've got some specific questions, we can try and talk about it if you want.
Okay.
Okay?
It's such an excellent example of how to make double quotes nest. Because in the answer equals line, you have double quotes inside of the command substitution.
Mhm.
And
You have double quotes inside.
And you have double quotes outside, which is a very good idea. That didn't used to work, but it does now. Yeah. You used to have to backslash the inner ones. Yeah, it was very ugly.
Yeah. But this does work on all recent versions of.
So, why do you want the quotes outside? Is the one part that I'm not?
The quotes on the outside?
Suppress reevaluation.
Oh, I see.
Well, actually, you want the quotes on the outside because if there are any embedded white space in this result,
Yeah. No, I see.
you want it all assigned to the.
Yeah, I missed
Yeah.
the assignment portion of it. That's why.
You're still in some danger because if anything that got returned by exec SQL looked like a variable reference or command substitution, add substitution suppresses that.
I think it does.
Yeah, it might.
Pretty
Yeah.
sure it
And
does.
you can have quotes inside of that too, actually, because I worked around that issue as well. So if the result of the exec SQL contains quotes, it's not going to end the starting quotes over there. So that's the other thing that kind of happens. It's some weird, like you said, it's 12 passes per.
Yes. Oh, yeah. It's just amazing. It's complicated too.
So this is just a simple assignment of a single column, single row result to a variable.
That's just gonna spit out 42, right?
Yeah, I would just spit out 42.
That's a long story for
So now in this example, I have 2 columns and potentially many rows that are going to be returned. So this is actually an example of, I was talking earlier about a here string.
Okay.
So this is taking basically the output of this, which might be multiple delimited columns and multiple rows, and it's going to feed them into this while, and it's going to read them as 2 separate variables, PID and age. And so now inside of the do loop, I can actually individually manipulate the 2 columns. And I'm going to do that in a loop, so I'll get all the rows.
So this works well because your output is already set up, but if you have anything else that would be variable, that would throw it out the window.
Like if you had a variable number of columns.
Yeah, or if you have nulls in your responses.
Yeah, if you had nulls in your responses, you'd have to. You could get around that by using coalesce, right?
Well, yeah, because your IFS unfortunately is not by default. The default separator is space and UI. And
Yeah, you can actually. I think there's an example later where I set the IFS in the
Okay.
while, and you can do that.
Yeah, because otherwise yeah, you run into weird stuff.
But your query is probably safe because you're always going to answers that they're populated. You're not going to see nulls or empty
In
spaces.
this particular query, it's completely safe.
Being a Windows guy, I gotta say it's a heck of a lot more elegant than PowerShell.
Yeah. In theory, PowerShell is better.
In
In theory.
Okay, it's not.
Yeah. No, it's true.
The idea was good. Implementation was just
Microsoft.
So one of the things when I was doing this scripting, I wanted to be able to make use of SQL functions, mostly PGSQL, maybe some SQL. But the issue that you run into there is, because sometimes it's better to just let the function execute right within the database, because that makes sense given whatever you're doing. But then you have this problem that your script needs to be kept in sync source code wise with your function that's in the database, because maybe today that function takes 2 arguments and next week it takes 3 arguments. And so you want to be able to ensure from the bash script that the version of the function that you're executing in the database is actually the version that you want.
Nice.
So what this function, again, it's in the common lib, is going to do is figure out an identification of a function based on the combination. Now Postgres identifies a function based on a combination of the schema name, the function name, and the argument list, the argument data types, basically. So that is the signature that is used by Postgres to resolve a particular function for execution, because Postgres supports overloading. So you can have 2 functions with identical names. One of them takes 2 arguments, one of them takes 3 arguments, or they both take 2 arguments, but one's taking an int and a text, and the other one's taking a text and an int. And those are 2 separate functions. But I've added another element to it, which is basically I'm taking the function definition, which this pgget function def using the OID of the function, that gives me right out of the database what the source code was that went into creating this function. and I'm doing an MD5 over it. And that's one of the elements I'm going to return. So now I have a complete description of not only the function that's going to get executed, but the version of it.
So you just gotta hope that nobody's just gonna go update the comments of what works and nothing else, because
Yeah, well, I've actually provided a script that lets you,
strip out the comments, so just make sure it's just
it gets you the, and it extracts a SQL file which matches exactly what this thing expects. And then there's another script that will recreate the function based on that SQL file. And that was actually one of the reasons I did that, was so I could reverse engineer all the stuff that already existed. So I just point that thing, one script at a database, and it would create a SQL file for every function and every view. And then a script would run on all the SQL scripts in that directory, and it would recreate them in such a way that all this logic would work.
that's a very useful thing.
So this is basically telling you what I just described. The schema name, the function name, and the argument types is the actual function signature, but the MD5 provides the actual version of it. So then this is the bash function for creating a SQL function. And what it's going to do is it's going to take that SQL file I was talking about. I came up with a naming convention for this file name, which is basically a combination of the schema name, the function name, the argument types, and the MD5. And so it parses all of that information out of that SQL file name. And calculates the MD5 of the body.
The trouble I've had with that is getting the functions in the right order when I'm reloading things. They often care.
If there are dependencies, yeah.
Yeah.
In this case, if the functions already exist, all you're doing is create or replace, it doesn't matter.
Yeah.
So that was never a problem for me.
Yeah.
If you really want to figure out what the order is, use pgdump, because pgdump will figure it out for you.
Actually, could you use a nasty trick and making the assumption that the OID is going to be the order in which they were created, so you can sort of assume?
No, because if it's, well, first of all, OIDs can wrap.
Yeah, I know, but
And
the
there's
line-
also create and replace. Which
Oh,
typically-
right,
yeah.
that's going to update that.
Well, create and replace does not change the OID specifically.
But that would then confuse things
And actually, none of that is going to be bulletproof, because it's entirely possible to dynamically execute SQL inside of PLPG SQL, and Postgres will never know there's a dependency if, for instance, you reference another function. So
Yeah, okay.
it's possible to still get yourself in trouble with that, but
one of the
Yeah,
things that I
it's
wanted,
the
yeah.
most generic cases.
Yeah, I've done horrible glitches like pre-process the Postgres code to stick in SQL function calls which count where we are, either line numbers or object numbers in a file, and stick that in the comment. Yeah, stuff like that. Or
and the dynamic SQL that I just talked about isn't typically a problem, because until you actually run the function, it won't matter if it doesn't exist. But you can get into some issues. Generally speaking, pgdump is going to figure out most of the dependencies for you, though. So in this case, what I'm doing is I'm using this this function I described before to figure out whether there's a match, and then if there is not, I'm going to execute the file in order to ensure that the function that I am calling is the right version. Yeah, the one I was referring to that. Where did you see that?
At the very top, PG.
oh yeah, here it is. Very first line.
Oh yeah.
Yeah.
So this is another syntax for saying if this thing is not defined, throw an error. With the dash, set dash u, I don't really need it, but it's also generally good practice to use that. And you can see I wasn't exactly consistent with it though. So if I don't have a match, I'm going to create a replace. So this is an example of creating a SQL function, and then this is the script. And again, this is all the stuff up in this stuff is all up on GitHub. This script will dump existing functions and create the file according to the spec that the naming spec that I was just talking about. So finally, in an actual bash script that's using some function, this is sort of the flow. You would say, here's my SQL file. You can see the naming convention I use, so schema dot function name dash argument. There's more than one argument. These are the OIDs of the argument data types. So if there's more than one argument, it would just be underscore another ID, OID underscore another OID.
Names could be very long.
If you had a lot of arguments, but OIDs are all going to be relatively, they're going to be like 2-character OIDs, so it's probably not going to be that horribly long. So here I call the function to verify that I'm using the correct one, and then here I just use it. So once you've done all of that prep work, the actual bash script that's doing the function call is fairly simple. You basically just have this extra couple lines in here before you use it.
Why not put the verify inside the exec SQL? Oh, just kind of keep them separate.
Yeah. They're really doing different things. I mean,
Yeah.
exec SQL isn't necessarily calling a function at all.
Yeah, that's true.
So now I'm on to the examples of things that are not really Postgres specific, but it can be useful when you're bash scripting around Postgres. So in some cases you want a concurrent execution interlock. You want to make sure that the script only runs once. So that could be important if the thing you're running might run over a really long time, particularly if it's like, let's say it's on an hourly cron job, and if something bad happens, it could take an hour and a half to run. What you don't want to have happen is job runs long, second copy of the job starts up, now things get slower still. Third time, next thing you know, you're stacking them up, right?
We used to have nightly jobs, and when the databases would get too big or not handled, they would run over 24 hours, and you'd go log in later and be like 5 or 6 or more of them. Of course, they're all waiting on each other.
Right. You're just making the problem worse.
Yep.
And the other thing is sometimes concurrent execution can cause damage, right? If you've got a script that puts things into a certain state and then the next script starts up and things are in an unexpected state, that could cause damage. So, forcing vacuum based on some criteria or, and this is an actual example. I mean, in one case, we wanted to force auto vacuum to happen in sort of a custom way. And so there was a script that was running on cron. We checked the size of the table, basically the estimated number of rows in the table. If it exceeded a certain amount, it would set a custom scaling factor for auto vacuum, which would cause auto vacuum to run more frequently.
That's a good question. I'm just trying to understand a little. So what kind of jobs are you running? When you set up this script, what kind of jobs are you pulling? Are they programs to do some analysis on data sets, or what kind of jobs? Because you're talking about
Most of the
rows and columns.
most of the jobs that I'm talking about in these examples are doing either some kind of maintenance or some kind of monitoring, or maybe some kind of automation. So automating a failover, or automating provisioning of a new system, or automating an upgrade.
Most of mine are web backending, so they're generating the contents of the web page and dealing with the dynamic issues of the web page as well.
You can output data as well, but that's probably not the best use of a shell script.
I have used shell scripts to do automated testing too, quite a bit.
That's I was actually curious about that because I'm not sure how, but I would like to set up. I have certain programs that need to be run at a certain time per week or at a certain interval. Like
Mhm.
sometimes it's once every 3 months. And I was thinking, but I'm not familiar with setting up programs to run this way. How to set them up to run automatically. So
Is it something that runs from the command line, or is it something that runs through a GUI of some sort?
I try to run it through the command line, but the place where I work at, it's set up, the command line, it's not flexible. It's
Is it running on a Linux system, or is it running on Windows?
Windows.
Okay, well, Windows has a way to automate tasks. I mean, I've used it, I'm not super familiar with it. Actually,
Tasks.
yeah, the task
I saw
scheduler.
that, but
Now, you say you're using SQL of some sort?
Yes.
Is that MS SQL or Microsoft SQL? Or
Well, these are SaaS jobs that are actually calling SQL, it sounded like.
right.
Like I say, if you're calling MS SQL, potentially you need some SQL because they've got a.
Yeah, but if it's a SaaS, but SaaS runs scripts, right? So doesn't SaaS have its own way for scheduling jobs?
No, not really.
But with it, starting with 2012, you can do command line scripts, you can do PowerShell scripts, you can do darn near anything, and just treat the agent. I think most databases people want to do that, but that's okay.
I'm pretty sure that SaaS has a command line program that will allow you to run a SaaS script. And if the SaaS script knows how to call SQL Server, it'll just work. But the details, without knowing, I've never used SaaS myself directly, I just know a little bit about it. Now, if this was all in a Postgres database and you wanted to use R, I could talk to you about that all night.
I know a little bit of R, but right the moment I just use SAS, so I'm trying to find more information on that.
Yeah, well.
So this function interlock is going to, this is what I'm going to use to create literally interlock, so that I can say that when I start my process, I'm going to lock at a certain point. And then I can call this in such a way that either another process coming in will wait, in other words, it'll block and sit there and wait, or you can also immediately exit with an error. That's basically what this action non-block means. Don't sit there and wait, and if you don't use that parameter, then it will block. So the actual command line program is called flock. I'm saying I want it to be an exclusive lock. I want to use whatever action was chosen. And remember, all the way at the beginning when we were talking about my enum, am I doing an unlock? If I'm not doing an unlock, so if I'm doing an unlock, it's on the next page here. If I'm not doing an unlock, that means I'm doing some kind of a wait, or some kind of a lock, and so I'm going to test, am I doing a no wait? If I'm doing a no wait, then it's non-block, and if I'm doing a block, then then I don't need that. And if for some reason this is the syntax for figuring out whether the last command what the return value was. So I'm just going to set that to this variable RV for return variable, return value. And I'm going to test is return value not equal to 0. If it is, I'm going to say that I couldn't get the log.
So that would go back to what I asked about the C.
Yeah.
Return value with the C. So there you go.
Right.
So your exec will always succeed.
Yeah,
While it
that's,
will be
that's
present in the D.
the exec is a
This exec?
redirector.
Yeah, that will always succeed.
This is,
Even though you have exclusive
There's something interesting here, actually. Flock is specifically written to log something as a resource, but it actually can fail. So the safest thing you can actually do is the one before that, which is you just pick a number for one of the file descriptors and pick it. You have to fix it, and that's what you can use as the safest thing. But you're going to run into issues with flock only if your system is basically running at 100 plus. So if it's spinning in place is when flock is going to fail.
Yeah,
But I
and
had that. I ran into situations like that.
well, that's good to know.
Yeah.
Typically, for the types of things I'm using this for, I'm not fighting race conditions like that.
Yeah, no,
And this is the way to dynamically allocate just an available file descriptor, which, when I first did this, I was just picking a number, like you said. I just hate the hard code stuff like that.
I'm with you, but if you need to make sure that one job, that's it, you have to designate. There's no other, I could not find any other way that I could actually safely determine that's the case.
So probably if you were in that situation, another way to do that is in that common script, you could just have another enum for file descriptors for various uses, and just use that one. That way, at least you'd have a descriptive name in there.
yeah. It's maybe also worth mentioning that this is highly unfolded code, which is just what you want for tutorial, because you can see where to stick in other missing code. But if this were all you were writing, then this actually would shrink down to much less code. Like, you could just say if flock and not capture the status. But if you're going to be testing that more than once, then you have to do it this way. And you can use double parens and get rid of the not equal 0.
Right.
But this is the generic way of doing it, which then kind of shows you what else you could do.
Well, and the other reason I do this is if you're working in an environment where there's a lot of people potentially working on the same scripts, you want them to be readable so that the next person coming along can figure out what you did.
Yeah, this is very friendly, unfolded code. You won't get to see code this friendly. Most of the code out there will be very tight, but kind of like
Obfuscated.
I write that way actually most of the time because I wrote stuff that I could not understand.
Yeah, I find, like I said, I gave this presentation in June, and if I hadn't written it this way, I would have a heck of a time explaining what was going on myself, even though I wrote the code.
Well, I like this because somebody who's learning from this, they can see how they can change it around. Whereas when you write it kind of shorthand, yeah, it works for that specific thing, but now you want to change it around and you don't see how to do it.
True.
So I've seen a couple of different places now the set plus E thing. I was just wondering, what if like say for this case you have this specific function you want to run with a set plus E, but maybe in other places you don't. Is there a way to get the state of whether you're running with a set plus E or not, so that when you're done you can set it back to whatever it was before the function was called?
It's an awful way. You can do a set dash O and pipe. You can do a set that just basically shows everything that's set, and then pattern match on that with a case. But I wonder if there is a way.
I don't know of a way right offhand.
Yeah, I don't know the direct future.
I know that you can do set plus E even if it's already plus E, right? So that won't throw an error if it's already set.
Right,
So if you know you want it that way, it's safe to do that here. But you're right. I'm sure there's a way to figure it out in code, but I don't know how to do it offhand.
Yeah, I was just wondering, like, say you have one function that you always want to run with plus e, and one function you always want to run without plus e. What would that minus e? What would happen if they were constantly swapping again?
It's not a problem because they're synchronous, and you can but yeah, how did it say set it back to what it was?
Yeah.
Yeah.
Basically, using a push semantics instead of a push and pop instead of set. It's a good question.
Yeah, I'm not sure offhand. That's
I know
something I'll have to
Oracle
look.
is doing it, but they're not worth it.
Okay. Thank you.
So the other cases where we're trying to unlock, so that one's a fairly simple, and in this case it's going to do unlock with the file descriptor. So, and it is an example of using that. In this case, I'm just going to use a sleep in this script. Again, the script is on GitHub if you want to play with it. I'm going to try and grab a lock in a non-blocking mode. So this is what the no wait does. Basically test to see whether I was able to get it or not. If I wasn't able to get it, so if my return value is not 0, then I'm going to try again in blocking mode and sit there and wait. And so you can show if you run this in 2 separate terminals. Basically, you run it once, it's going to sleep for 10 seconds. So as soon as you run it, you can come over another terminal, run it again, and you'll see it go through the locking logic.
Is the double preferred now?
This is preferred. It's actually more functional than the old style. The old style, the single bracket was actually executing the test program.
Well, there's two actually. I was reading about this recently, so that's the reason why there's actually a bin bracket and then there's actually a built-in. So depending on how you do it, if you don't do it right, it's gonna. So if you do it on a command line, I believe if you don't put an if in front, it runs the command. If you put an if in front of it, then it actually uses the built-in.
I don't think so.
I believe that
I think the
in
built-in is
Bash-
the double
I
bracket.
believe that in modern Bash they're both built in, but in the
Really?
in the corn shell, double, which is where this comes from, the single runs test as an external, and double is built in. But
In any case, this is the recommended
yeah,
usage.
one thing is it's POSIX standard, and then it will work with any version of the corn shell or Bash.
I'll start using it.
I know it's hideous, isn't it?
I know on CentOS 7, the bracket is still in user bin. So
Well, it's still there. The question is whether Bash is figuring out that it should use the internal one or
It
the
uses the
external one.
internal.
Well, that's gonna go across beforehand. It's just gonna do internals.
So another example script is doing parallel work. This is where you want to launch multiple asynchronous processes and wait until they're all complete. This could be useful for doing PG dump across multiple servers, multiple long-running queries. I've used it in a situation where we had a Sloaney cluster with 3 nodes, and we were wanting to do basically a restoration of the whole cluster at once from some backup files after it had been shut down. You can't just do this very easily. But for this particular use case, I think what we were doing is actually cloning an environment just for a test environment, and so we wanted to stand it up as quickly as possible. So what you don't want if you've got a 500 gigabyte database is to load this one, sit there and wait until it's done, load this one, sit there and wait until it's done, right? What you want to do is launch all 3, and then that way they're all more or less finishing at the same time, and so you're done in 1/3 of the time. And you'd like to be able to launch that from one place, from one script.
So there's a group of functions that start showing up that handles a lot of that stuff. You feed it one job and it knows how to actually run it as many times as you need to.
Yeah, there's a couple different ways to do that. There are some, I forget what
They're
the,
basically wrappers. They're
yeah.
really more complicated versions, basically. So I was wondering if there's a reason why you wouldn't want to do that, or
I didn't want to, in this case, the environment I was working in was tightly controlled, particularly on higher instances and closer to production. And so you couldn't just install packages that weren't there, for instance.
Okay.
You didn't have root on the box.
That makes sense. That's a good.
So yeah, there are some things that you can load that would make this easier, but I was trying to stick with built-in stuff with Bash.
Makes sense.
So this particular example is going to launch 3 queries as a background task. It's going to wait until they all complete, and in the example, if you didn't have parallelism, the whole thing would take 15 seconds, and with it, it takes about 5 seconds. So you can see here, this is very similar to the one I did earlier, all the connection string info. I've defined the sleep time as 5 seconds. There's my query again, and I'm going to sleep 30 seconds. Maybe I need to update my slides.
Is that
Yeah.
what 15 seconds came from?
That's a pretty good 15
Uh,
seconds.
Well, I'm just wondering
So-
update this by singular 15 seconds.
Actually, I think I got it right in here, though, so. Yeah, you see I'm using sleep time there.
Yeah.
So I actually got it right there. I need to fix the slide.
That's what, so you should ran 3 times and it took 15 seconds and you ran 3.
Right, so if this just happens serially, and each one sleeps for 5 seconds, then the whole thing's going to take 15 seconds to run. This is one method, right? So you can, basically by putting the ampersand, each one of these things goes out to a separate process and immediately returns. And then the wait command is going to wait for all child processes of the current process. So this will work fine in terms of getting the parallelism. The problem with it is that you cannot gather the result. So if all you're doing is, loading 3 things and you don't care about the answer, then this is a good way to do it. There's also this built-in called coproc, which is interesting in that it does allow you to get back the results. The downside is there's some bugs, at least in all of the released versions of Bash that I've found, that mean you have to do some ugly things. So in this case, I actually have to define a 4th process, because whatever the last process that was defined, the value never gets returned. It actually executes, but no value gets returned. So by having this, basically this bogus one that's just going to sleep for a second, I can actually harvest the results of the first 3.
Does it have to do anything, or could it be just a true?
No, this is just, probably could just be been true.
Okay. I'm just curious. To sleep.
If you're doing something that takes a long time to run, sleeping for a second doesn't hurt,
it's
right?
no big deal, yeah. I don't like sleep in general. That's too much. I did not know about
So your last process doesn't have to.
Well, like I said,
take as long as
the fact that I'm doing this is a workaround for the fact that if I didn't do this 3rd one, when I read the buffer, I get nothing. And I actually did some research on it, and it's a bug that's been in Bash for like 7 or 8 years. I mean, I found complaints about it 7 or 8 years ago, and it hasn't been fixed yet, which doesn't give me any comfort that it's going to get fixed soon.
I did not know about
The other thing is it does give you these bogus warnings.
Oh, really?
Yeah. But it gives you the results, and you can see that it runs in 5 seconds, which means all 3 of them are happening in parallel.
That's not good.
No, it's like I said, it's kind of ugly. It'd be nice if it got fixed, but
That's just telling you you did that, right? That's all.
well,
Keep
This
input
is a
warning.
warning. It's
It's coming as a warning.
yeah, it's coming as warnings.
not even an error, it's just a warning.
It shouldn't be there at all. All right, so the final example is automating cleanup. There's something called trap. Reasons you might want to do this is if you've got partial changes. We talked earlier how a complicated script might make some changes, and then if you have an error part of the way through, or if someone hits Control-C because they get tired of waiting, or kill it by saying kill PID, any of those things is going to leave you in this indeterminate state potentially. So by registering a trap, you can have a task that runs on exit that will go undo some stuff for you. Another reason you might want to do it is to keep track of progress. So, and this is a real example again. We had a script that was doing migrations of Postgres using Sloaney, and we wanted the whole thing automated with a script. And there were lots and lots of steps, and there were lots of Sloaney steps. And if you've ever worked with Sloaney, it's not always deterministic. So sometimes things would just fail, and then you try it again, and they'd work fine. And believe me, I spent months and months working on this, and we never could, no matter what we did, eliminate all of those failures. And you know, some of them I blamed on random network infrastructure kind of glitches, but whatever it was, you would run this script, and we had hundreds of instances that we needed to run it on, and about every fifth or sixth time you'd get an error, and you didn't want to have to go all the way back and start over again. So you can actually use traps so that when the script errors out, I've got basically a marker that's keeping track of what step I'm on, that I'm changing every time I proceed.
It's essentially building start restart logic in the script.
I built it right into the script, and now when the thing runs, when the script ends, the trap would output that step that I errored on into a file, and then I had restart logic that would just use that and skip everything before it and go right back to where I was and just keep going.
Yeah, I deal with that stuff now, like creating a VM, for example, doesn't always work. And no rhyme or reason really as to why. Maybe there's just no machine that's up at the time. Who knows? It just says error. If you have a whole thing built that depends on one of the VMs being instantiated, then you're kind of stuck. So this does happen before.
Yeah, there's I think plenty of use cases for it.
Yeah.
And like I said, cleaning up temporary files that you might create along the way. So in this example script, it's going to set some undo traps, which are going to truncate a table, truncate from one table and insert into another. It's kind of contrived example, but perform some DML, which is going to insert into a table and truncate the other table. And then on error or a SIGINT, which is Control C, the trap's going to run, and if the script completes successfully, the trap does not run. So the same stuff at the top that we've been seeing. I'm setting up I wanted to be able to simulate whether an error was thrown or not. So that's what this is doing, whether I pass an argument or not. If the number of arguments is equal to 1, then I'm going to say throw an error, and if it's not equal to 1, it's not going to throw the error. In order to facilitate the trap, what I did was I created a function called cleanup, and what that's going to do is loop over an array and evaluate every item in the array. So that way I can actually pop undo actions onto a queue and then have them execute in reverse order. So here I declare array as an array. There's a SQL statement. The element that's going to go into the array is going to be this logic here, which is going to execute truncating table and then run my execute SQL function with this SQL that says truncate table T1. And so I set the array element to that, and then I'm going to do the second one like this. So as I described earlier, so this is going to insert some values into T2. And this is what I have to do to set the second array element.
Yes.
Very ugly, but it works. And then this is the syntax for setting a trap. So the trap is going to execute my cleanup function, and it's going to do so whenever it receives a SIGINT signal or an error.
Cleanup takes no
takes the array which is already defined.
Okay.
And actually, I mean, if you get into some of these evaluation issues if you try and pass it. So then this is a case where you don't want to use local. So now I'm going to do basically just the opposite of my trap. I'm going to insert some values into T1. I'm going to truncate T2. I'm going to select count from the tables to see what rows are in there. If my thrower is defined, then I'm going to tell you that you can hit Control C and sleep. So this is the way I could attest the Control C was working. Otherwise, I'm going to complete. So now here's actually what it looks like when it's running. And basically, you can see that when the trap runs, it restores things. And here, I let it complete successfully, and so I end up with what I did, whatever I tried to do without the trap running. And that's it. Huh?
I have the answer to how you find out whether -e or the other things have been set.
You do?
There's a variable $, which outputs the string of all of those things that are in a non-default state. And so you do case $, and then e-paren.
Interesting.
Yes.
Thank you.
Yes.
Yeah, it's $1 in almost anything that's not. It's gonna do something.
Yes, it will do something. There you go.
H is 6.
Yeah. So if you do case $, yeah, there you go.
Yeah, so you can see there's the E now.
Yeah.
Oh, dude.
That's good. I'll have to remember that. I don't know what to choose for it, but
Yeah, I don't know Oliver how you use for
But
it
I
either.
like, is it Michael? No. William. Yeah, well, because William was saying, how can you make those things local to a function? In other words, restore them to the way they were. And so if you could say, yeah, you could save that. You could save it all if you wanted and restore them all.
Right.
Or you could, yeah, you could just fetch the one you want into a local.
The reason I was thinking about it is I read a lot of functions that are used for, so my job here is I do automation for my own developers. So I'm writing a lot of functions to make
So you can do that.
They have their own settings of how they want those things ran.
Right.
And me setting things like this messes with them sometimes.
Right.
So
Yeah, I mean, ideally you'd be able to put the word local in front of anything, but you can't.
yeah.
So you see what I did on the screen there? I just set a variable equal to that, right?
Oh yeah.
And then I can say set plus UE, which should take away the UE, right? So now if I did a